So we're today at Sycamore Creek, which is up just south of Payson. It's a tributary to the Verde River. We have a gauge here because this place burned about 6 years ago, and the Forest Service asked us to put a gauge here. So part of the Sycamore Creek stream gauging system we have above me is a radar sensor. This radar sensor, rather than measuring water level from below, measures it from above. It shoots a beam of radar down, and as the water level rises, it can measure the level of the water that way. Here at Sycamore Creek, we have something that's not necessarily installed everywhere, but we have it at a few locations. This is a status sensor, and what this does, it doesn't necessarily measure the level of the water, but when the water hits a certain level here in the sensor, it'll trigger a switch inside of it, and that will tell us back at our office that the water has reached a certain critical level that we need to be more aware that there is rising water here at this creek. So part of Sycamore Creek, we're working with the U.S. Geological Survey, and they've installed what they have called a continuous slope area reach, or CSA, and that involves at this location a data logger, which is low to the ground, and it consists of a pressure transducer as well, which will record the level as it rises and falls, and they can come back, and actually they have to come back and download this data, take it back to analyze it. But this allows them to give us a continuous slope area, continuous discharge of what's going on here, so that we can figure that out after the event. So some of you may wonder how we determine how much water is actually flowing through a wash when it does flow. Not just the height of the water, but how much volume is flowing through it. And we want to calculate the volumetric cubic feet per second. And how we do that is a match of geometry and mathematics. So we survey a cross section here, which is perpendicular to the flow. As water is flowing upstream to downstream, we survey the cross section this way. And as you can see, as I move down, it's a little higher here. As I move down to the lower part of the cross section, this area will obviously contain more water, and it'll be a little bit faster through here. And as it goes up to the other bank over there, it gets higher and it'll have less water in it. So what we do through mathematics of calculating the cross-sectional area, at this one we calculate one upstream, we calculate one downstream, which gives us the slope of the channel. From there, we can determine how much water is actually flowing through this in a volume amount. So that's how we convert feet of water to cubic feet per second. So here at Sycamore Creek, as at most of our stream gauges, most of the level is measured with a pressure transducer. And we have one here that I'm going to demonstrate for you. So I took the cap off, which goes here, and inside there's a diaphragm. And as water hits the diaphragm, that's when pressure goes against it, and it begins to show the water level rise as it's going up. And so with a calibration, it knows when 1 foot of water is actually here due to the pressure differences. Is as it continues to rise, the pressure increases, and our system knows how to convert that into actual feet of water level.